meeting of the day. I am Dr. Kavita from MBA department. Today we will do our next topic, that is binomial distribution. That is also a kind of distribution. It is a theoretical distribution. So let us start. So probability distribution. As we started earlier, the probability we have already done the some concept of simple probability. Now we will do some distribution. In statistics, we have two kind of distribution. First is observed distribution, observed frequency distribution. Second is theoretical distribution, which you can say expected frequency distribution or probability distribution. In all situation, it is not possible that we collect real data. And in case where we are not able to collect real data, we can depend on probability. Probability distribution is really very important distribution, as it solves many business problem. There are three type of basically distribution: probability distribution, normal distribution, Poisson distribution and binomial distribution. So let us start first. What is the difference between probability distribution and observed frequency distribution? In case of observed frequency distribution, what we will do? We collect data. This is based on real data. We collect data. Suppose there is a class of 30 students and we want to know the actual marks in their test. So we can collect data, actual data related to their marks, related to their height, whatever variable we want to study, we can collect actual data from those 30 students. That will be considered as observed frequency distribution. But sometime it is not possible to collect data, then we can rely upon theoretical or probability distribution. So today our topic is theoretical probability distribution, and in this we only do we will start only binomial distribution today. So theoretical distribution or probability distribution, it is also called expected frequency distribution, because it is based on expectation, right? It is not based on real data. And then what are the uses of expected frequency distribution or probability distribution? What are the uses? Why we use this type of distribution? First use is analyze the nature of given distribution under certain assumption. Remember, in every kind of theoretical distribution there are certain assumptions, like in case of normal distribution, like in case of binomial distribution, and in case of Poisson distribution. These are the three type of distribution where assumptions are different, and we will do assumption in our next slide. Then to obtain expected frequency, suppose we want to know what are the expected frequency of any variable, we can know with the help of theoretical distribution, right? Number 3, to compare actual and expected frequency. Suppose we have some actual data and we want to check that whether if we collect data from this distribution, from probability distribution, is there any difference or no, right? If there is no difference, we can rely on this type of distribution. Then to make prediction, suppose you want to make prediction about the weather, about the profit of a firm, you can predict on the basis of probability distribution. Then useful in solving business problem. You all know in business there may be different kind of problem, and to solve those problem we can use probability distribution. Like suppose we have two kind of distribution, like Poisson distribution and normal distribution. We can use Poisson distribution in making quality control. Suppose if we want to focus on quality, we can use for quality control we can use Poisson distribution, which we will do in next class, right? And suppose we want to know what can be the size of, suppose we are running our garment ready-made garment business, we want to know about the sizes, what can be the normal sizes, we can use normal distribution for that. Then these are some uses, and then there are different type of theoretical distribution. What are the type? There are basically two types, continuous and discrete. Discrete probability distribution and continuous probability distribution. In discrete we have two kind of distribution. One is binomial and second is Poisson. Today we will do only binomial and we will do only some aspect of binomial distribution. Poisson distribution, and in continuous we have normal distribution. So let us start with the binomial distribution. So first today we will do only binomial distribution. It is a very important distribution given by James Bernoulli. Given by James Bernoulli, and this is a very important distribution where we require two things, that is success and failure. Success is denoted by P. P is used for success of event, right, and Q is failure. These are the basic concept of your probability, and definition of how you are going to define probability distribution in case of binomial distribution. There is a function probability of x is equal to NCX. You can write NCR or NCX, right? You can write NCX or NCR. I am writing both, Q into Q n minus x into P power x. So you can write NCR as well as NCX, right? This is the formula to use combination. We can find out various combination. So here what is P? P is probability of success. What is P? Probability of success. And what is Q? We can find out it like this, 1 minus P also, you all know. This is the probability of, because these are the basic concept of probability of failure. And then what is N? Number of trial. Like suppose you toss a coin thrice, then number will be 3, because you toss that coin 3 times, so N will be 3. So in this way, and what is the probability of getting Q? That will be 1 by 2, and what is the probability of getting P? That will be 1 by 2. So there are some assumption and conditions or assumptions. Remember, in every type of theoretical distribution there are some assumptions or there are some conditions which you have to follow before applying that theoretical frequency distribution. So let us do what are the main condition. First is finite number of trial. Finite number of trial. What it means? It means you can count the number. There should be the number of trial should be finite. For example, you can say 3 trial, 4 trial, you toss a coin 4 times, 3 times, 7 times, right? So you can count, it should be countable. Then second assumption is mutually exclusive outcome. Mutually exclusive outcome. So each trial must result in two mutually exclusive outcome. One time only either P may occur or Q, failure or success. Suppose if we are talking about the tossing of a coin, only one event can occur, one outcome can occur, like it may be head or it may be tail, right. Then third assumption, the probability of the probability of success, the probability of success in each trial, in each trial should be constant. Constant. For example, suppose we toss a coin first time, then probability of suppose our success event is head, having head. The probability of head is 1 by 2. So it should be in second trial, in third trial, it should be same, it should be 1 by 2. You can't say that in first trial the probability of getting head is 1 by 2 and in second trial it's 1 by 3 and in fourth trial it's 1 by 4. No, it can't be there. Only in every case, in each case, the probability of getting head will be 1 by 2. Then last assumption, trial are independent. Trials are independent. There is no dependence between the different trial, means the first trial, the second trial is no dependent on first trial. Suppose if we get in first trial a head, that it doesn't mean that in second trial we get head again or we get tail. It may be tail, it may be, or it may be head. So there is independent of different trial, right. Then coming to the most important part of binomial distribution, that is property. In each case of theoretical distribution, it is the main part, property or characteristics of the distribution. So let us start with characteristics or property of binomial distribution. Properties or characteristics, you can say characteristics of binomial distribution, right. So let us start with first one, that is theoretical frequency distribution. As we earlier discussed, it is a theoretical frequency distribution, right. So it is very clear to you. So all the three distribution, binomial, Poisson and normal, all the three distribution are theoretical distribution. Second property is discrete probability distribution. As we earlier discussed about this is discrete probability distribution, because we have two type of distribution. One is continuous and second is discrete. In discrete distribution we have two distribution. First is binomial distribution, which we are doing today, and another is Poisson distribution, which we will do in next lecture, right. Then third point, very important, when you plot a graph, it will be a line graph in case of probability distribution. As in case of normal distribution we have bell shaped graph. In case of binomial distribution we will have, if we plot the value of our distribution, it will be line graph like this. So it will be like this, suppose like this, because we have given frequency in discrete term, right. like frequency may be 1, 2, 3. Suppose there is an example, a small example we will do with example, right. On n axis we write the px, probability of success of event, and here we write the number of success, here number of success, this is probability of success, number of success means x, right. For example, suppose we have having a question example like here we can have number of head, which is our success. Suppose we toss a coin twice, right. Then suppose for example when we toss a coin twice, success may be, suppose our success is head, so we can have 0 head means no head, we can have 1 head, we can have 2 head. In this manner when we toss a coin twice, एक सिक्का जब हम 2 बार उछालेंगे तो इस तरह से होगा आपका, then what can be the probability, because when we apply the formula as discussed in previous slide, then previous page, it will be like this. So it will be, and in case of second 2C1 don't worry, we will understand this formula in next page, that we will be 1 by 2 and then 2C2 1 by 2 power . So this is 1 by 4, this is 1 by 2, this is 1 by 4. If we plot like this, so we can say the graph will be in the shape of line graph, right. And we will learn this formula and this example in coming pages. So don't worry about that. Then come to fourth. Characteristics number 4, shape of binomial distribution. What will be the shape? Shape of binomial distribution, it will depend on the value of P and Q. If first case, there may be 3 cases. First, if P is equal to Q is equal to 1 by 2, means P and Q value is 1 by 2, P and Q are equal, then the distribution will be symmetrical, distribution will be, shape will be symmetrical, shape will be symmetrical, right. If second position can be, if P is less than Q, means P is less than 1 by 2, then this will be asymmetrical, asymmetrical means skewed, or you can say skewed, sorry, it will be skewed and positively skewed. Third case can be, if P is greater than Q, means P is greater than 1 by 2, then it will be again skewed and negatively skewed. So in this manner, the shape of a binomial distribution will depend on the value of P and Q, Where P is equal to Q is equal to 1 by 2, distribution will be symmetrical, and where P is greater than Q then negatively skewed, and when P is less than Q then positively skewed. And shape will be like this. In case of first, this will be the shape like this, right? And in case you can see, if you draw like this, this will be like this. Then in case, it just for example, right? So like this. And in case of second case, if you plot the values, the graph will be like this, right? So it will be positively skewed. Skewness is like, you can see the positive side, right? And in third case, the graph will be like this, right? So you can see negatively skewed. So in this way you can have shape of binomial distribution, and you can have three kind of shape of binomial distribution. Now come to next property, that is main parameter. The fifth property is main parameter. What are the main parameter in case of binomial distribution? In case of binomial distribution, main parameter are n and p. And in normal distribution, it's about binomial distribution, and in normal distribution we have x bar and standard deviation. Then come to point 6, constant of binomial distribution. What are the constant? Constant of binomial distribution. First is mean, that is n into p, right? Then variance, you can denote like this with the help of this, that is npq. And standard deviation, very easy, square root of variance is your standard deviation. Standard deviation denoted by sigma, so that is npq, right? And moment of skewness, means how much skewed is your distribution, that is under root beta 1 by is equal to q minus p divided by npq, or you can say divided by q minus p divided by standard deviation. Then moment of last constant, moment of kurtosis, moment of coefficient of kurtosis, moment of coefficient of kurtosis. Right. So moment of kurtosis we will do on next page. Last constant, moment of coefficient of kurtosis. Which is denoted by beta 1, denoted by beta 2, sorry, beta 1 is used for 3 plus 1 minus 6 pq divided by npq. So this about the different kind of constant which are used in this distribution. So where and last property is uses, where you can use, right? So it has been useful in those field where outcome is classified into P and Q. Where you can use, where we can classified the outcomes in P and Q. P means success, Q means failure. Like tossing of a coin, rolling of a dice, right? Drawing a card from a pack of card, right? So in this way we can use the binomial distribution. Then what are the application of binomial distribution? This is the very important and practical aspect of this topic. There are 4 uses. Today we will do only one use. I am writing all the 4 uses. First is application of binomial distribution formula. First, binomial distribution formula application. Second, to find NP. To find N, P and Q from, suppose you have given x bar and standard deviation, then you can find out the value of N, P and Q. Then third application is to find out, this is the reverse to second, to find out x bar and standard deviation. Here we can find out N, P and Q if we have given mean and standard deviation, and in this reverse if we can find out x bar and standard deviation if we have P, Q and N. And last application is last use of fitting of binomial distribution. Fitting of binomial distribution. So let us do first application for today only. We will do only first application, right? So that is how we can use the formula, right? I am writing the formula here again. So formula is NCX, you can write NCR as well, NCX into Q N minus X P power X. First of all, I would like to make you understand the formula, that is NCX. First of all, you can write down how to solve NCX, right? So how you can write it? NCX. What is N? N means total number of any trial, X means number of success. So this is, you can say, total number of cases, this is favorable cases, right? Like this. You can solve with N factorial divided by, write down this because it is very important, R factorial, oh I am using here X, so I will write X here. You can use R and X as per your choice, then N minus X factorial. So in this way we can use this formula. So let us do with example, so that the formula can be more clear in your mind. So we have some examples. Let us do some example. Suppose example number 1. Suppose a fair coin is tossed. If fair coin is tossed thrice, and we have to find probability. Find probability, find the P. I am writing P only for the probability. Find the P of getting, probability of getting. P means probability. Number 1. First case is exactly 2 head. And we have already discussed about the probability of tossing one coin, tossing two coin and tossing three coin in earlier video. So, you can see that video to make more clear concept about the tossing of coin and how you can find out the probability of tossing of one coin, tossing of two coin and tossing of three coin. Then second, at least two head. Means at least minimum two head, we can have three head also because we thrice a coin, because we toss the coin thrice, we can have three head also. Then at most two head, at most two head, it means we can have zero head, we can have one head, we can have two head, right. So, let us start with first this is your question, then let P is the probability, let P is the probability solution. So, P is the probability of getting head, that will be 1 by 2, right, and Q, as you all know, in case of tossing a coin, that will be 1 by 2 because there is 50% chance of getting head and 50% chance of getting tail. So, here N, because coin is tossed thrice, thrice means 3 times. So, N is 3 here, P already written, P is 1 by 2, Q is 1 by 2, right. And in first case, and we have the formula, that is, this is our formula, Px is equal to Ncx Q की power n minus x P power x. So, let us start with our first example. So, in first case, they are saying that we should have exactly two head, right, exactly two head is the success. So, we will write the probability of having two head in first case. So, we will write like this, total number of trial is 3, our n is 3, then C x, we want 2 head, so write down 2 here, right, then Q is 2, 1 by 2, what is the value of Q? 1 by 2, and then N 3 and x is 2, then again, right. Then how to solve this? So, when we solve 3, we will write 3 factorial, 3 minus 2 factorial into 2 factorial, right. So, 3 into 2 factorial divided by 1 factorial into 2 factorial. So, 2 will cancel by 2, then remaining will be 3, and here we can write it like this, 3 into here 1 by 2 power 1, 1 by 2 power 2, you can write it like this. So, we have probability 3 into 1 by 2 into 2 into 2, that is 8. So, in first case, probability of getting exactly 2 head is 3 into 1 by 8, that is 3 by 8. So, the probability of getting exactly 2 head is 3 by 8. Now, come to second, they are saying at least 2 probability of at least 2 head, means we can have 3 head also because coin is tossed thrice. we can have, so probability of at least 2 head will be equal to probability of 2 head plus probability of 3 head. As we calculated already the probability of 2 head, there is no need to calculate the probability of 2 head, but still we can calculate it again. So we can write the probability of getting 2 head plus probability of getting 3 head like this: 3C2 1 by 2 power 1 plus 1 by 2 power 2 plus getting exactly 3 head C3 1 by 2 power 0 1 by 2 power 3. So we can have 3 into 1 by 8 plus the solution will be 3C3 will be 1 into 1 by 8, that is 3 by 8 plus 1 by 8, that will be 4 by 8, and after solution it will be 1 by 2. In this manner we can have the solution for our second solution. Then last, second point, then last, suppose we want to know the probability of at most 2 head. At most 2 head means we can have 0 head, it will be equal to 0 head plus probability of 1 head plus probability of 2 head, right. So we can do in second manner also, or we can write total probability is 1 minus probability of 3 head. We already calculate the probability of having 3 head. Probability of having 3 head was 1 by 8 in our last. You can see probability of having 3 head is this 1 by 8. So 1 minus 1 by 8, that will be 7 by 8. So in this way we can find out the probability with the help of binomial distribution, right. So this is for today, next we will do in next class. Thank you.